Hi everyone. So type errors. There's been dozens of research papers explaining or investigating how to improve type errors in ML. But for some reason, none of these ideas have ever reached the OCaml compiler. This is a problem because beginners can get completely stuck by incomprehensible error messages. And even I sometimes get very frustrated that the compiler tells me the error is here, whereas it's in another place. And I'm sure many of you have had experienced the same frustration too. So what I'm going to present here is a patch to the type checker that works as follows. It basically type checks all your code using the standard OCaml type checker. And if it runs into an error, then it's going to type check again the top level definition that contains the error, using a slightly different algorithm that hopefully will provide you with a better error message. So I'm going to take you through the list of features of this new algorithm through a collection of examples starting with very simple ones. Here's a little program. Every beginner makes this mistake, forget the couple of parentheses after the greeting. And the problem is that the error message says, it has type unit to int. But when the beginner writes this program, it doesn't know anything about function, and the error type is just completely mysterious to it. So why not help the beginner by telling me, probably you forgot a couple of parentheses here. Okay? It's a very simple thing to do. And the general rule is that whenever we want to unify unit to t, and it fails to unify u with u, we just plug in this little message here. Okay, very simple. We can play a centric with a bank operation. If you have a mismatch like here between, say, an int ref and an int, let's suggest the user to maybe add a bank somewhere. Okay, we don't know exactly if this is a place where it's missing. It could be missing in another function, but as a general rule, we can say that we probably forgot the bank somewhere, and we failed to unify a to ref and a u. Yeah?
What was the line? You said that it's at line 2 that you forget the unit.
Yeah, on the X. The error is, I didn't change the location of the error. It's still on the application of print into X. Well, I changed it slightly, but it's on. Yeah, no, it's on the failure here. I mean, the first line is perfectly valid. You just don't know that. Okay, so very simple. Let's continue with one more trivial thing. Very often, beginners, especially if they've programmed in another programming language before, forgot the rec. And then they read, oh, facto is unbound, but wait, let facto, that's a binding. What are you talking about? So, little help. Maybe you forgot the rec keyword, like one. Okay, very easy. General pattern is you look up in the scope, maybe if the variable that is unbound was bound by a let rec instead of a let, it's very likely that the user missed the rec. Okay. True. All right, one more. I really like this program because it's perfectly valid from a semantics point of view. It says if x is less than y, return the list xy, and otherwise x is more than y, so you return yx. Beginners write this code very frequently. The semantics is fine, but you get a cool error message. It says the constructor column does not belong to type unit. Wow. All right, let's think about it for a minute. What would be a better error message? Anything, right?
Something is wrong.
Okay. So something that you can do is to say, well, look here, you have a conditional without else branch, so the then branch should have a type unit. Okay? And even if the beginner doesn't really understand the second part of the line, he will see that it's missing an else, basically. The message will say that. So what's the general pattern here? If you have an error because the subterm of a particular language construct is expected to be of a given type, in this case here it was unit, then we can add a few words to explain why this was the expected type. Okay, so then you can play this game for arguments of conditional, arguments of while loops, and so on. And here it was for the then branch. Without an else, it should be of type A. Okay, so far we've looked at very simple things. All of that is implemented like in just less than 100 lines of changes to the type checker. Now I'm going to show you something a bit more challenging, is trying to address something called the left to right bias. in the type checker. Here you have a Zen that has a given type in the Zen branch. It doesn't match the type of the right branch, the else branch. And the type checker will always report the error in the second branch, but half of the time the error is actually in the first branch. So a better thing, more helpful thing to do is to say, okay, the Zen branch has type int, the else branch has type float, the two just don't unify. Okay? We're not trying to guess which branch contains the error because we just can't tell. So the general pattern here works for conditional and pattern matching is you type check the branches completely independently, or at least quite independently, and then you try to unify them, and if you get an error, you report the type of the different branches, and you can see the error. So I want to point out that this doesn't remove all the left to right bias. Is that your question? No. No, I say branches up to now have type int, and this branch has type float. Okay, so there remains nevertheless some left to right bias. To see why, consider a function here that takes x, and in the then branch it prints it as an int, in the else branch it prints it as a float. So the x was unified with int in the Zen branch, and now we get an error in the else branch because it doesn't match the float type. So you can see how some information is flowing across the different branches. I'm not trying to get rid of that because it's really hard, and it doesn't seem to me so necessary to get rid of this information that flows, because here you're going to get an error on the print float x. Note that the compiler can tell if print float should have been print int or whether x should have been casted differently. So we get an error here that involves x, and then it should be quite clear to the user that x should be playing here. And adding a type annotation on the x shows maybe that the problem was in the first branch, that you should have maybe written print float here in the first branch. Okay, so summary is we don't remove all of the left to right bias, but a large amount of it. And I think it's a good improvement. Okay, so let's see what happens for functions and how we remove the left to right bias in function applications. So here there's a call to array make, and I just swap the two arguments. And the type checker will always say, the first argument is not good because it doesn't have the right type. But this is an error that you can only understand if you have in mind the type of make. So why not recall what make expects as argument? So here's a new error message. It says array.make expects two arguments of type int and a, and provided floats and int. So now it's kind of clear that maybe we swapped something. The general pattern is to report when an application fails to type check the error on the entire application, and to recall the type that were expected and the types that were provided. So this is a general pattern, and I'm going to show you on more examples how this works out. First of all, consider the application of plus. OCaml gives you an error on the 2.0 here. It says, they should have type int. Well, why? I've seen beginners get completely stuck on programs like this. Where is the error? I can't tell. The problem is the actual error is beyond the point where the error is reported. And this is something very counterintuitive, that the actual error will be beyond the point where it's reported. So the new error says plus expects two arguments of type int and int, but it was given two arguments of type float and float. Now it's very obvious that you are not using the right plus operation. Okay. The same applies to missing parentheses around -1. Before you get an error with sucks, the suck being a function not of type int. Okay, very confusing. But now the new error says minus expects two arguments of type int and int, and it's very clear that minus has been parsed as a binary operation and not a binary one as you wanted. Okay, so I'm going to conclude with examples involving higher order functions. These are the ones that you might be most interested in as advanced OCaml programmers. So list.map, give it a function that acts on integers and a list of floats. OCaml will always blame the second argument because it has this left to right bias. But what I'm going to do instead is to report all the types. So list.map expected A to B and A list, but it received int to int and float list. So now you can kind of see that int, A must be int, and therefore it's not float. So you have to do some of this unification by hand, but you have to do this anyway to kind of understand the error message. And what I like here is that you see the type that was inferred for the function, for the anonymous function that you passed to the iota function. And that's kind of helpful for debugging, I believe. Last example, one with full left. Classical bug, you swap the accumulator and the name of the item. Okay? And if you're not lucky, you get one of these fancy errors. Type variable A occurs inside A list. Yeah, it does indeed. Okay? Not too sure. And the error is reported on this X here, which has nothing to do with the problem. New error message says full left expects a first argument of type A to B to A, but you provided C to C list to C list, and then you immediately see that you swap the two arguments. Okay, in summary, so there are some custom messages for the missing parentheses, bang and rec, messages for handling particular subterms of language constructs. We did not remove all of the left to right bias because this is really hard to do whilst remaining with concise error messages, but we decreased a lot of this bias. And in particular for binary reporters, we no longer report errors before their actual position. What I've not shown is that this also works for functions with labeled arguments and named optional arguments. However, I have no support for JDTs, so if your code involves JDTs, you will only get the usual OCaml error, nothing better. And also, there's no change at all to the type checking of modules. Right? This is completely autonomous. So I encourage you to give it a try. Thanks to Andy-Ray, you can try this online at this URL here. And you can have an you can use open switch if you want to try to see how this helps reporting errors in your everyday OCaml program. And please send feedback to know either if things need to be fixed or if maybe you're interested in seeing this in the mainstream compiler one. Thank you.
We have just time for 2 quick questions.
Yes. So Arthur, this seems too good to be true. I mean, seriously, why would we want the old error messages? I mean, I don't even try to read them anymore. Who reads error messages now? So tell me, what's the catch?
I think you have to try and see when you have functions with many arguments, very complex types, if this works out, and this is why I'm seeking for feedback.
Okay.
Because, yeah, I usually write functions with few arguments and simple types. So, I wouldn't be a good judge for that. So please try and tell me.
Maybe a related question, which is the left to right bias. I can see why you don't want to have that in the type checker. But the rest of the stuff, it looks like it could be made the default, basically. So why don't you do that? Especially when you just add an extra line, like you probably forgot. We could have that today.
Sure. It's part of a package. You take it all up.
Last question.
Yes.
I just have one more for you. This expression has type T, but an expression is expected to type T.
Oh yeah, that's a different one. That's a different one.
Yeah.
Well, Damien, let's do it quickly.
Out of curiosity, how many of these techniques that you implemented were already in the literature?
In the literature? So, for the first part, the missing rec, no, I've not seen that in the literature. No, for the left to right bias, there's been lots of studies, but usually either the algorithm is too expensive, or it produces error messages that are too big or too complex, or it tries to find the shortest path or a different path to explain the message. And yeah, I can understand why it's hard to scale that to the entire language, and even to get messages that are better on all cases than what OCaml was doing before.
So there'd be more principal approach to typers, but they're very expensive, and if you use it, it's a very cheap way to get perhaps 80-90% of them. Let's answer Arthur again.